This is MAlKindi. I'm from Oman. I'm junior at ESU. I'm studying electrical engineering, and today I'm gonna talk to you about the radio system and the way we transmit the waves, and from three different classes: signal and system analysis, electromagnetic, and electronics principles. So let me talk to you about the simplest radio antennas, which are long straight rods. They take the form of a dipole antenna, a metal rod split into two pieces and folded horizontally, so it looks like a person standing straight up with their arms stretched out horizontally. The waves arriving at antenna form transmitter are exactly the same, no matter what shape and size the antenna happens to be. A different pattern of dipoles will help to concentrate the signal so it's easier to detect. Example of dipole antennas are directional antennas, and they are forced on a radiated power into a narrow beam, which helps adding enough amount of gain in the process. This kind of antenna is used to radiate or receive more power in certain directions, which improves the performance and reduces the interference from unwanted source. Therefore, directional antennas is used for long-range communication, and that's one of the main examples we need to discuss in this assignment. However, weather can be a factor that affects the propagation of radio waves, which decrease the strength of transmitted signals. Rain can cause attenuation to the wave signal because water has much different permittivity than in a sunny day, and raindrops can cause attenuation by scattering the electromagnetic waves, and that leads to a decrease in the effective range of the signal. Not only rain, but large storm with lightning has much more damage and bad effects, as we know that lightning can produce high enough electric field that can cause disruption to radio and TV. Let's move on and take a look at the radio system diagram that I'm gonna explain in a little bit. So if you take a look on the red box on this picture, so we can see that the signal is gonna go to the amplifier, which is a normal voltage amplifier that's used for low frequency signals. This amplifier does not have effect on the signal frequency as it's shown on the diagram. And then the signal is gonna go to the mixer. The mixer that's connected with on parallel with the amplifier mixes and selects the right frequency from the obtained. Let's assume that we have a frequency of 550 kilohertz. The mixer selects the local oscillator frequency to make the antenna transmittable, even though it's high. That's because the low frequency cannot carry much information, but it has less noise than high frequency signal. And now let's look at the power amplifier. And the power amplifier is a little bit different than the normal voltage amplifier. Power amplifier is used for multiplication of radio frequency signal. However, normal amplifier is used for audio signals as well. This amplifier takes the signal and processes it to make it suitable for driving a loudspeaker. And finally, the bandpass filter, which is connected at the end of this diagram and is used to eliminate the frequency of the input signal. The bandpass filter takes the highest or lowest frequency depending on the signal, which is called noise. And at the end, the operation of antenna is controlled by the switch duplexer, as you can see on this diagram. and this duplexer selects whether the signal is gonna be transmitted or received. Assume we have a multiply signal, two of them, and the output is y of t. Assume that the first signal is passband voice signal, and the carrier signal is given as cosine omega naught t. Let's see how we gonna, when we put these two signals into the mixer, how is the output is gonna look like. So in order to get the output y of t, first we convert cosine omega naught t to the exponential form, which gives ej omega t plus e negative j omega t all over 2, and then we multiply x1 to this equation, and as you can see we find half x1 of t e to the s naught t plus half x1 t e to the negative s naught t. And from the table we can find the Laplace transform of this function, which is gonna give us half of x1 omega minus omega naught plus x1 multiplies by omega plus omega naught, and that's the solution of, I mean the output of the signal. Everything for today. I hope you enjoyed and understand how signals on the radio waves works, and thank you for watching. I hope you have a good day.